Now, question 5. The owner of the right, so the rail car makes a short journey from one terminal to the other. So you've got an acceleration time graph that maps its journey. So use the graph to determine that the steady speed of the car in the middle section. Okay, so what we can do is we know that the acceleration is 0 to begin with. So that means that either the object is stationary or constant speed. So when we're going to make it assume it's at rest to begin with, because the rail car's at the platform, so it's going to be at rest. Then it accelerates once it starts to move. Okay, speeds up. So the acceleration is instant. This is like the instant that they put the foot down on the pedal or move the throttle up. And we see that is 3 meters per second squared for 8 seconds. So we've got an acceleration of 3. We've got time for 8 seconds. Acceleration and time, we can use that to get the change in velocity. So we know that the change in velocity during this acceleration is 24 meters per second. Okay, so the speeds increased by 24 meters per second. So if you start off at 0, you've increased the speed by 24 meters per second. You're going to end at 24 meters per second. Okay, so that's the speed that the car has gained as you've accelerated for those 8 seconds. Now, the next part, it says show that the rail car comes to rest at the end of the journey. So if you are initially at 24 meters per second after the acceleration period, now for the rest of the section from 18 seconds to 60 seconds, there's no acceleration. So the rail car is at 24 meters per second continuously for the time between the terminals, and then it starts to decelerate during this next 6 seconds. And let's find out what we can work out. We can again work out the change in velocity, and the change in velocity is the acceleration. So the acceleration was minus 4 meters per second squared. That's 6 seconds between this point and this point. Okay, each mole square is 2 seconds. So we can work out that the change in velocity, just like we did before, is acceleration minus 4, this is a negative sign, times by 6 gives us minus 24 meters per second. So if we know that we were coming in at 24 meters per second, we change our speed by minus 24 meters per second, we're going to end up back at rest at the end of the journey. Okay, so it decelerates from 24 meters per second to 0 meters per second. Okay, now we can also look at the fact that what we've actually done is we worked out the acceleration, which is the width of this kind of rectangle, times by, the height of the rectangle multiplied by the width, which is the time. So the time is horizontal, the acceleration is vertical. We essentially worked out the area. So the area of this section here, the area of an acceleration time graph, gives us the change in speed. And we can see that the area here and the area here are exactly the same. So the increase in acceleration, the increase in speed here is the same as the decrease in speed there. That's an alternative way to look at it. Right, part 3, I don't want you to worry about too much because what we'll do is we'll come back to this question later on when we look at energy and power. However, I'll just leave that there for a couple of seconds. You can pause it to have a look at what I've done. So here is a bit of an explanation of why we equate these two. So if you want to pause and have a look at that, you can. Right, next, question 6. We've got